Hi, 7th graders. Tonight we're doing lesson 1-9, so you can open your book and follow along with me, starting on lesson 1-9. Sorry, I don't have the page number right next to me. We're talking about solving simple, so just basic one-step addition and subtraction equations using the vertical method. We touched on this in 6th grade, so this will probably be a little familiar to you. So thinking about the addition property of equality, that tells us that if you have two numbers, you add a number, same number to both sides, you will get the same number on each side. So we have 7 equals 7, 7 plus 3 equals 7 plus 3, so 10 equals 10. Same with if we have a variable thrown in there. So over here, on our algebra side, if we have x minus 5 equals 6, well, x minus 5, if we add 5 to one side, well, we know that if we add 5 to the other side, it's still going to stay equal. We also know that negative 5 plus 5 equals 0, so that cancels out, so we have x equals 11. Same goes for subtraction. If we subtract a number on both sides, same number, we get the same answer. Same goes with if we are adding x plus 4 equals 6. Well, if we have x plus 4 minus 4, 4 minus 4 is 0, so we're left with x, and then we have 6 minus 4 equals 2. So basically what we are learning from this is that addition and subtraction are inverse operations because they undo each other. Well, what does that mean? Inverse operations undo each other. So let's relate it to going to school. So you start at home. So I'm gonna pretend that I'm starting at my house and I'm going to Rosemont Middle School. Okay? I'm gonna type this so it doesn't take me forever. If I leave my house and I get to the main highway, which is 46, I take a left on 46. I take that all the way to Highway 3 and I take a right on Highway 3. Then from Highway 3, I take a left on 143rd Street. The school will be on my right, if I could spell. Okay, coming home from school. So if I leave school, the school will now be on my left. I take a right on 143rd Street from the parking lot. Then I take a right on Highway 3, and then I take a left on 46. Okay, so see how it's opposite? I'm going to school, and then when I'm leaving school, I'm going home, it's the opposite. So sit and think about what direction you take to school, and then how you're doing it the opposite way to get home. So basically, you're kind of undoing all of the directions for you to get home. Okay, so now if we have a problem, so let's do our problem and figure it out that way. So if I have negative 9 equals x plus 7, I want to solve for x. I want to figure out what number plus 7 equals negative 9. You can probably think in your head, maybe, and just figure it out that way. But eventually we're going to have way trickier problems that you won't be able to just figure out in your head. So if you recall from 6th grade, all teachers taught differently, but our first thing before we even start our steps is that we want to make our railroad tracks, which are not very straight when I'm using a mouse. Okay, those separate each side from each other. So we know we have everything on this side needs to be equal to everything on this side. And if you recall from 2 previous slides, Whatever we do to one side, we have to do to the other because we have to keep them balanced. Okay? So our first step, we find the side with the variable. Our variable is our letter, so we're starting on this side. Now we do the opposite operation on both sides with the number on the side with the variable. So what does that mean? So the opposite of addition is subtraction, and then we take this number and we're going to subtract it because 7 minus 7 is 0, and then we're going to be left with x. And over here then we're going to subtract 7. So negative 9 minus 7, negative 9, we can do chop minus, same sign, so we add them together. We get 16, and then we keep the sign. So x equals negative 16. And then the last step, which I forgot to include, but you should always check your work. So negative 9 equals negative 16 plus 7, and we know because 16 minus 7 is 9, then we take the negative sign. So it works, so we check. Okay, let's try another one. So first step, make my railroad tracks. I don't know why that is in a box, but I'm just going to leave it. We find the side with the variable, this side. We see that we're subtracting, so we have to do the opposite, which is adding, because our goal is to get rid of this extra number on the side because we want the variable alone. We want to know what number minus 10 equals 9. So then over here, we have to add 10. Whatever you do on this side, we have to do the same exact thing on this side. So we have x equals 19. So these would be good problems for you to be writing down in your notes. And then we check, well, does 19 minus 10 equal 9? Yes, so that's our check. Okay, whatever your solution is, you should be able to plug it into your variable and then solve. So here we have really bad railroad tracks. Okay, remember I'm doing my railroad tracks to separate each side from each other. It's just my visual way of showing that this is a side and this is a side. And the equal sign just carries on down. So we have x plus 3 equals negative 7. Opposite of addition is subtraction. Minus 3, and then we do minus 3 over here. So I pull down my variable. If it helps, sometimes people like to cross it off, and that's fine with me. Whatever works for you. X equals, so we have negative 7 minus 3, so we do chop minus. Negative 7 plus negative 3 equals negative 10. Negative 10 plus 3 equals negative 7, and then I ask myself, well, is that true? Yes, it is, so we check. Okay, try these problems. Pause me, do it in your notes, and then come back and check, and I'm going to be checking in your notes to make sure that you have actually done these problems. So let's change the color. So here I have, I'm going to spare you with my uneven railroad tracks. I'm just not even going to draw them. So we have, actually I am. I'll just try to do them nice and neat, because it's a good habit to get into. So we're going to subtract 5 on both sides, because we have addition. Opposite of addition is subtraction. So x equals negative 7 minus 5 is negative 12. Railroad tracks, my variable is on this side, so I know that I have to add 8. Add 8. Y equals 20. Okay, this time my variable is on the right side, so now I'm looking at this side. So this is where it gets confusing because usually our variable is on the left side, but not always, so we can't always assume that we're going to start on the left side. So we have x minus 2, so the opposite would be to add 2. Add 2. Negative 9 plus 2 is negative 7 equals x. So as you're solving these problems, this is all of the work that I want to see. All of this, not just the answer. Even if you can do it in your head and even if you know how to do it, I still want you to get in the habit of solving problems like this and writing out all of your work because you're eventually going to need to. Okay? Sometimes I like to put a line underneath, actually. So we had adding 5, so we're subtracting 5 because it's the opposite. So we have A equals negative 11, or we would say negative 11 equals A. Okay? And then for all of these, we can go back in and plug it in. Negative 11 plus 5 equals negative 6. So it checks, and we're good. Okay? Make sure you have your notes down. If not, you should probably go back and redo some of the problems that we did. And you can also look in the book if you're still confused, and then take the NAICU quiz. And I'll see you tomorrow.